Hello class, in this video we'll be discussing the topics of counting, permutations, and combinations. A little background on these topics. In this section, in the majority of problems that we'll be working with, we're trying to answer some form of the fundamental question, how many different ways can something be ordered? And you're going to see through some of the problems that we'll do why this is a relevant question, and also see through the problems we do how you can answer that question. So let's just start with a little example. Let's say that you have a yellow, red, and green tile. And a blue tile. So you have four different tiles. One of them's yellow, one of them's red, one of them's green, one of them's blue. And the question is, how many different ways can you arrange those four tiles? We've already explored some problems like this, but for example, you could arrange them just the way that it's written, Y, R, G, B. You could switch the green and the blue, Y, R, B, G, and so on and so forth, and you could write out all the different ways that you could arrange these tiles. Now, we should be interested in, is there a more efficient way to do this process other than just writing out all the possible ways that it can occur? And the answer is yes. So more specifically, we want to rely on the multiplication principle. And in this application of the multiplication principle, what we're going to do is we're going to write out our first tile, our second tile, our third tile, and our fourth tile. And for each of these, we're going to identify how many different choices we have for the first, second, third, and fourth tile. So when we're choosing from yellow, red, green, and blue, and we're choosing the first tile to pick, we're always going to have four choices because all four of them are available. Once we've chosen one, regardless of which it is, the second tile, we now only have three choices available. And then third, we only have two choices available, and then finally we only have fourth. We only have one choice available. So the total number of ways that we can arrange these four tiles is 4 times 3 times 2 times 1, which would be equal to 24. There are 24 different arrangements for these. This is an example of one of the important topics that you're going to see in the book called a permutation. Permutation is in contrast to another similar but slightly different topic called combinations. The way we differentiate between the two is you know you're dealing with a permutation when the order matters. When the order that you arrange something matters. Let me give you an example. Going back over here to our colored tiles, yellow, red, green, blue is going to look different than yellow, red, blue, green. So although we used the same four colors and all we did was switch the order of green and blue, those are going to look like two different arrangements. So the order matters in this case. When you're working problems and order matters, you're dealing with a permutation of objects. So a permutation is an arrangement of objects in a specific order. When we're going through the definition of a permutation, one of the things that you'll need to know to be able to work with the definition is what is a factorial. A factorial, the mathematical symbol for a factorial, is the exclamation point. You may have seen an exclamation point used before mathematically. So n factorial is defined as n times n minus 1 times n minus 2, all the way down to times 1. Now, that's a pretty difficult definition to wade through, so let's give an example, and you'll see that it's actually a pretty simple concept. 3 factorial is 3 times 2 times 1, or 6. 5 factorial is 5 times 4 times 3 times 2 times 1, and so on and so forth. So we're literally just multiplying up all the integers from 1 up to the number that we're taking the factorial of. The reason this is important is because our general definition for a permutation is given in terms of a factorial. Let's go ahead and state that, and the definition is going to look pretty complicated, but don't worry, we'll do a couple of problems to help you better understand what's going on in the problems. Okay, so our permutation definition, you're going to see this in the text as well. We have a lowercase n, uppercase p, and lowercase r, and that is equal to n factorial divided by n minus r factorial. So it's 1 factorial divided by another. Now, we need to understand what each of these elements, the n, the p, and the r, stand for. You probably could have guessed that the p just stands for that we're dealing with a permutation. The n and the r, though, have significance in each problem. The n is the number of objects, and r answers the question, how many at a time? Now, that's a little bit vague still because we haven't done a problem that involved a certain number at a time. So let's go ahead and do that. And I think as we work our way through this problem, you're going to have a better understanding of what this definition means. Okay, so let's say, for example, that we have a soccer league with 7 teams. And the question is, how many ways can the teams finish first, second, and third? Okay, so you see where we're going with this. Let's just say that the teams are the names of the teams are A, B, C, D, E, F, G. Well, the teams could finish. A could finish first, B could finish second, and C could finish third. Or it could be B, D, F, or it could be C, E, A, so on and so forth. When we first start looking at this problem, the first thing we have to address is this a permutation or is this a combination? Now, if you haven't watched the combinations video yet, you obviously need to watch that as well. But going back to what we said over here, how we determine is this a permutation of objects or is this a combination of objects is by asking the question, does order matter? So how do we determine that in this problem? Well, is A, B, C the same thing as A, C, B? In this case, no. If you ask teams B and C if these are the same two, they would obviously say no. Both teams would rather get second place than third place. So there's a difference between B getting second and C getting third than C getting second and B getting third. All of that to say, in this problem, order matters. Okay, so we're dealing with a permutation. Now, from there, it's pretty self-explanatory what we need to do next. According to our definition of a permutation, we need to start with the number of total objects that we're dealing with. In this case, our objects are the number of teams in the soccer league. So we have 7 soccer teams, and what we're looking for is 7 soccer teams chosen how many at a time. So this gets back to this R variable. In our specific problem, we're only caring about how teams can finish first, second, and third. So each time we choose a set of teams to be first, second, and third, we're choosing them 3 at a time because we have 3 spots to fill. So we want 7 teams chosen 3 at a time, which we would shorthand write as 7P3. Now you're going to find that if you have a graphing calculator, or all of you have access to the internet obviously, you can find calculators that will do this calculation for you, okay? So you can punch that in. We can also go ahead and rely on the definition for this problem. So 7P3, according to our definition over here, is going to be 7 factorial divided by 7 minus 3 factorial. And we could calculate that all out, and we would find out that the answer is 210. Now, before we end this video, I just want to make sure that we're on the same page in analyzing this solution. 210, in the context of this problem, would indicate that there are 210 possible different ways that the 7 teams could finish first, second, and third. So, to close, when you're working these problems, here's the steps I would like you to follow as you're working through them. First, determine, am I dealing with a permutation or a combination? From there, determine what is the total number of objects that I'm dealing with and how many am I taking at a time. Then from there, you can simply apply the definition of a permutation or a combination to be able to solve the problem.